All right, this is example 9, and this one is another calculator problem, and it asks us to find out when this function changes concavity. So what I'm going to do on my calculator is plug y equals e to the x times x squared into my first function on my calculator, my y1. And I just want to point out, if I look at this, if I just look at the graph, I have kind of an okay view. I want to zoom in a little bit. I think I'm going to make my window from, say, -7 to 7 on the x-axis, and I might do the same on the y. I'm just trying to get a little bit of a better view of what this graph looks like. And that helps a little bit. I think I see a concave down section and then a concave up section. Not quite sure what's happening over here. So visually, I'm not 100% sure whether I have 1 or 2 inflection points. So maybe I'll zoom in a little bit more. It's a little bit of a guess and check on where to zoom from. I'm going to just change my y values to -4 to 4 here to see if I can get a better view. Okay, that helps a little bit more. I do look like I'm concave up, then concave down, then concave up. So what I'm going to do next is, check this out, I can graph the first derivative. If I go back to y equals, go down to y2, and when I'm at y2, I can click on alpha window, and that brings up this list of calculus and other items. And n-deriv is the numerical derivative. If I scroll down to 3, I get this Leibniz notation for the derivative, which is really cool. So I'm always going to have x in my denominator right here. So I put in an x and it flips me over to this one. Now what I want it to do is get the derivative of the function in y1. So if I go to alpha trace, it brings up all of my different y values, and I want the graph in y1, so I'm just going to hit enter for y1. Now it's going to take the derivative of the function in y1, and then here, you don't want the derivative at a point, you want the entire derivative function, so you just put in an x there, and then you hit enter. So if I go back to the graph, what you're going to see is the original function, and then what gets graphed in is its derivative function. Pretty cool, huh? But I really wanted, well, I can do one of two things. I can actually look at the derivative function and find a turning point on the derivative function, because of course a turning point on the derivative is a 0 of the second derivative. Or I can go back here and I can graph in the second derivative. So again, I'm going to go to alpha F2. I'm going to choose choice 3 again, which is the numerical derivative. Still differentiating with respect to x, but now when I go to alpha trace, I want to choose y2. That's going to get the derivative of the function in y1. And again, I make this x, so it gives me all the values. And then the graph might get a little busy, so what I'm going to do is I'm going to scroll all the way over to the left of y3, then enter F, and hit the enter button several times until you get this key here. So this is going to trace the path of my graph. So you see the first two functions, and then you will see the third function coming through here. That third function is the second derivative function. You see it mapping through. It takes it some time. And I do think I'm going to have to zoom in a bit more so that I can see this graph. I might just hit the zoom button. And if I do a zoom, it's still graphing. I see up here. I have to wait until it finishes. Then I can do a zoom in. So zoom, choice 2, enter. And I'm going to get a better view of my 3 graphs. There's my original graph. There's my first derivative graph. It's going to take it a minute to graph. Could get the local min here because that will be an inflection point on the function. But here's my second derivative graph coming in with the trace key. And when it finishes graphing, I'm going to see that it crossed the x-axis here. So that is going to be an inflection point. So once I wait here till it finishes graphing, it's taking its time. Good old TI-84. Okay. Now I'm going to go to second calc, choose 0, and Notice that this automatically defaults to Y1. Click the down button twice and then it goes to the third graph. Then my left bound, I need to come over here to the left of the x-intercept and hit enter. Go to the right of the x-intercept and hit enter, and then guess. And I'm going to get that one of my concavity changes is at negative 0.586. And again, notice that I am using 3 decimal place accuracy. X equals negative 0.586. Now let's go back to my calculator because there should be another x-intercept over here to the left. So I am going to have to change my window so that my x-min is lower. Say I do a -5, hit enter and go to the graph, and I'm going to get a better view here because I think there is some concavity change in here. This is probably a max right here. And so in my second derivative graphs, which should be in a second, I'm going to see another x-intercept just about in here. Okay, I had to go back and regraph it. I paused my video and I have to go back and regraph it. So coming back to it, here's my first derivative getting graphed in. And this does take a second. I'm so sorry. And then we're going to get to the point here where we see another 0 coming in and we have to wait for it to finish graphing. And I have to wait until we get to the point up here where it's no longer graphing. Okay, now I can go ahead and hit second trace, and I want another 0. This time, oops, I have to switch my graph to the second derivative graph, and this time I look for the other x-intercept, which will be left bounded, then right bounded, and guess, and it's going to be at negative 3.414. And those are my 2 places where the function changes concavity.